Lesson 10.6, area of regular polygons, can be found on page 411 of your big book. Our essential question, what we're trying to do today, is finding the area of regular polygons. How do we do that? Regular meaning they're the same size, same shape. Same size, same shape. That's what regular means. Okay. All right, Emery is making a patch for his soccer ball. That must be a very special ball. The patch he is using is a regular polygon. A regular polygon is a polygon in which all sides have the same length and all angles have the same measure. So they're saying it better than I did, but it means they have the same size and shape. All right, Emery needs to find the area of a piece of material shaped like a regular pentagon. Penta means 5, so a 5-sided figure. So in other words, he needs one of these little purple pieces to fix his soccer ball, because these are 5 sides. These are not. This is 1, 2, 3, 4, 6 sides. Okay. So you can find the area of a regular polygon by dividing polygons into congruent triangles. Congruent, once again, means same size and shape, basically. Okay. Draw line segments from each vertex to the center of the pentagon to divide it into 5 congruent triangles. So why do we want to divide this into triangles? Well, because I don't know area formula for a pentagon. I do know area formula for a triangle. Remember, it's area equals 1/2 base times height. So that's simple. So basically, I'm just going to divide this pentagon into 5 triangles by drawing a line from the center to each of the 5 vertices. So this is one of the 5 triangles in this pentagon. All right, find the area of the triangle. So we're just going to find the area of this triangle first. Okay, so we write down our area formula for a triangle. Then we substitute 20 in for B and 14 for H. I wrote H instead of 14. Okay, 14. So half of 20 is 10, right? Times 14 is 140. So the area of this is 140 centimeters squared. Okay, so now knowing this, that one of the triangles is 140, how do I find out the area of the whole shape? Well, I find the area of the regular polygon by multiplying the number of triangles by the area of one triangle. So I have one triangle here, 2, 3, 4, 5. So 140 centimeters squared times 5, right? Because each of these is going to be 140. So what is 140 times 5? Quick, do a little margin work in case you don't have that number memorized. It is 700 centimeters squared. So the area of the pentagon shaped piece is 700 centimeters squared. So that will help him buy the material to make the patch for his soccer ball. All right. So once again, we're going to do basically the same thing. Just this figure has more sides is all. So we're going to find the area of a regular polygon. Polygon means many. Poly means many. manly. Okay, let me try that again. Many. And polygon means sides. So a polygon means multiple sides. Okay. So not a specific number. This happens to be a hexagon because it has 6 sides. Hexa means 6. All of these words are from your Greek and Latin roots. Most mathematical and scientific terms have some Greek or Latin in their roots. Okay, draw line segments from each vertex to the center of the polygon. So once again, we're going to make a whole bunch of triangles out of this piece. All right, so all we have to do is find the area of one of these triangles, then multiply it by 6. We're going to have the answer. So into how many congruent triangles did you divide the figure? 6. It's always going to be the same as the number of sides. 1, 2, 3, 4, 5, 6. All right, find the area of one of the triangles. Area equals 1/2 base times height. This is our formula for a triangle. Substitute 4.2 for B, and they got that from here. That's the height. Oh, I'm sorry, that's not the height, that's the base. 4.2 for B and 3.6 for the height. And then we simplify. Well, I don't know about you, but I can't do this off the top of my head. So I am going to, but I can take half of 4.2. I can multiply those two together first, because half of 4.2 would be 2.1, right? These are both even numbers. Half of 2 is 1, half of 4 is 2. So I'm down to 2.1 times 3.6. And I'm gonna, whoops, I'm off the page, but I need a little bit of space, so I'm gonna do it up here. Some workspace. So 1 times 6 is 6, 1 times 3 is 3, placeholder 0, because now I'm multiplying from the tens or the ones place, so I need to multiply from here. 2 times 6 is 12, 2 times 3 is 6, plus 1 more is 7. So I end up with 6, 5, 7. All right, so 756. Is that right? Is it 756? Remember, I had 2 decimals in the original problem. 1, 2. I need this. I need a decimal here. Think about it again logically. 2 times 3 is 6. So the final answer should be somewhere in the ballpark of 6. Well, the final answer is 7 and 56 hundredths. So yes, it is close to 6. 7 is close to 6. So that's a logical answer. All right. Last step. Now we're going to find the area of the polygon. So the area of this triangle was 7.56. So each, let's get back up here again for just a second. So each one of these is 7.56, 7.56, okay, so I'm multiplying this 7.56 times 6 because there's 6 of them. 7.56 times 6 equals, again, don't know this off the top of my head. Gonna have to do a little margin work. 36, 30, 33, 42, 45. Okay, let's do this again. 6 times 6 is 36, 3, 30, plus 3 is 33, regroup the 3, that's 42, plus 3 more is 45. So this is 45.36. So the area of the hexagon is, because 6 times 7 is 42, 45 is a reasonable answer. So 45.36 meters squared is our answer. Okay, into how many congruent triangles can you divide a regular decagon? Deca means 10. So a 10-sided figure by drawing line segments from each vertex to the center of the decagon. Explain. Well, with our hexagon, we had 6 sides, so we could make 6 triangles. A decagon, a regular decagon has 10 sides, so we can divide it into 10 congruent, meaning the same, triangles. All right, so we can divide it into 10 congruent triangles. All right, in an irregular polygon, the sides do not have the same length and the angles do not have the same measure. It'd be something like this, where this length is longer than this one's even shorter still. It's not going to have all the same size. Even if it was like okay, that's irregular. Not all the sides and lengths are the same. So it's irregular. Could you find the area of an irregular polygon using the method you used in this lesson? So no, you really couldn't, because let's say you did find the center. These different pieces are not going to be the same length. You can't divide it evenly if the lengths are not the same. So the answer is no. You can find the center of the polygon, but I couldn't make triangles, could I? I got a couple of triangles, but these weren't triangle shapes. It just doesn't work. But you can't connect that center, right? To the vertices, which are the corners, to make congruent triangles. It's just not going to work. I'm not going to be able to make those equal-sided, equal area triangles. Oops, am I not on the... All right. So it has to be a regular polygon for it to work. It has to have all the same sides, all the same lengths. All right, here we go. A number of congruent triangles inside this figure. So all you have to do is count the sides, and you're going to find out how many triangles there are. So I've got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides, so there's going to be 8 triangles when I split it up. All right, so what's the area of each of these triangles. Okay, so each of these triangles is 1/2 times 5 times 6, right? 5 times 6 is 30. Half of that is 15. All right, so this right here, this is 15. So the area of the octagon, octa means 8, like an octopus, or doc-ock if you're a Spider-Man fan. Okay, so there's 8 of them, so I'm going to go 15 times 8, because there's 8 triangles, equals, again, don't know this off the top of my head, although I could probably figure it out. Okay, is 120 centimeters squared. So there's our answer. And you'll just keep doing that with the rest of these regular-sided figures. All right, let's take a look at our notes. So today we are on, what, 10.6, right? Okay. Area of regular polygons. Let's go here first. So you draw line segments from each vertex to the center of the regular polygon to divide it into congruent triangles. Find the area of one triangle, multiply the number of triangles in the polygon by the area, and you're going to get the answer. All right, good luck.